Assalamualaikum warahmatullahi wabarakatuh. My name is Rahimawati binti Abdul Rahim from Politeknik Syed Nasir Syed Ismail. I would like to present about textural and moisture optimization in gluten-free dumpling skin. This presentation explores how the textural properties and moisture retention of gluten-free dumpling skin can be optimized by manipulating the content and interaction of protein and starches. The demand for gluten-free food products has risen significantly due to growing awareness of gluten-related disorders such as celiac disease and gluten sensitivity. Alongside the increasing popularity of gluten-free diets among health-conscious consumers. Among such products, dumplings are a staple enjoyed across various cultures, but replicating their characteristic texture and structural integrity without gluten remains a major challenge. We know gluten is crucial for providing elasticity and cohesion in traditional wheat-based dough, and its absence in gluten-free formulation necessitates innovative approach including the use of alternative flour and special processing method. In this innovation, we use tapioca and sweet potato flour have been identified as alternative in gluten-free formulation due to their high starch content and functional properties. Investigating tapioca and sweet potato flour, we can analyze about protein impacts, which is examining the effect of protein content on texture, moisture retention, analyzing the ability to bind water and form a cohesive dough, and flour formulation, optimizing the ratio of tapioca and sweet potato flour in beneficial properties. The methodology, we use tapioca and sweet potato as a main ingredient. So method analysis I use is moisture content, texture analysis, protein analysis, and thermal analysis are employed. Flour formulation through a comparative analysis. Control, we use 100% tapioca flour. F1, 70% tapioca and 30% sweet potato. F2, 50% tapioca and 50% sweet potato. Meanwhile, F3, 90% tapioca and 10% sweet potato. From the analysis, I use ANOVA as a statistical analysis. We can see the analysis of gluten-free dumpling skin formulation if which varying ratio of tapioca and sweet potato flour reveal significant difference in protein content, gelatinization, temperature, moisture content, and springiness. The control formulation made entirely of tapioca exhibited the lowest protein content and the highest gelatinization temperature. In contrast, formulation F1 and F2 show considerably higher protein level and lower gelatinization temperature. The moisture content was highest in the control and decreased in F1, F2 and F3, with no significant difference among the latter three. Springiness was particularly enhanced in F1 and F2, indicator better elasticity compared to the control and F3. There were no significant differences in cohesiveness or hardness across the various formulations. This finding suggests that incorporating sweet potato flour and tapioca flour not only boosts protein content and elasticity but also lowers the gelatinization temperature, thereby improving the nutritional profile and processing efficiency of the dumpling skin. For texture, F1, F2 improve elasticity and chewiness, mimicking traditional dumpling skin. Meanwhile, control and F3 control lack flexibility and F3 show structural weakness. For moisture retention is the key to cohesion. So, F1, F2 synergistic water absorption, resulting in a cohesiveness dough. F3 excess moisture lead to structural weaknesses, and control lack cohesion, resulting a weak and crumbly dough. From this result, starch gelatinization, TSC analysis for different formulation of flour, which is made entirely of tapioca flour, show clear thermal transition marked by a series of endothermic peaks. The first peak at 34.5 degrees Celsius is likely due to moisture evaporation, as tapioca starch is known for its ability to absorb water. The following peaks at 44 degrees Celsius, 55 degrees Celsius, 65 degrees Celsius, and finally 75 degrees Celsius indicate stage of starch gelatinization, particularly influenced by the stage of high amylopectin content in tapioca. Since tapioca starch is mostly amylopectin, it generally has a lower gelatinization onset temperature. The multiple thermal transition suggests a gradual gelatinization process, emphasizing the alteration in granule structure and water absorption. This behavior is vital for creating a soft and elastic dough texture in gluten-free dumpling skin, underscoring the important role of tapioca in achieving the desired characteristic of dough. Starch gelatinization, unveiling the microscopic mechanism. For tapioca starch, lower gelatinization temperature, forming a gel early in the process. Sweet potato starch, higher Gelatinization temperature contribute thermal and elasticity. For molecular interaction, the glue that holds it together, FTIR result, identify hydroxyl and carbonyl bonds indicating enhanced water absorption and gelatinization. Meanwhile, synergistic interaction, protein and starch work together, creating a starchy network. Conclusion: the results show that the natural protein levels in tapioca and sweet potato flour have a significant impact on the structural integrity, elasticity, and overall texture of the dumpling skin. Increased protein content was found to enhance the dough coziness, chewiness, and resilience, closely resembling the desirable qualities of traditional wheat-based dumpling wrappers. The study highlighted that the degree of starch deterioration during cooking is crucial in determining both the moisture content and final texture of the gluten-free dumpling skin. Proper gelatinization strikes the right balance between a moist, permeable dough and firm, chewy texture after cooking. Implication and application. Feasibility: production of high-quality gluten-free dumpling is achievable. Insight: understanding protein and starch interaction is crucial for improving gluten-free food texture. Application: these findings have potential to enhance the variety of gluten-free food products.